Welcome to the second video in our series on similar triangles. In this video, we're going to talk about the difference between congruent triangles and similar triangles. So I'm just making this informal list here, and then I'll pull out the notes that you have. So to rewind, congruent triangles mean every side is congruent and every angle is congruent. There are 5 ways to tell if two triangles are congruent. And those 5 ways, I'm going to use the abbreviations, are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. In comparison to congruent triangles, this unit we're talking about similar triangles. Okay, so similar triangles are not the same as congruent. Similar triangles are one that's big and then one that's small. Maybe a dilation should be coming to mind here. Hopefully you're thinking about dilations. Okay, with similar triangles, the sides are proportional. That's the big difference. Sides are proportional. Angles are still congruent. So the sides are being proportional is the big difference here. We're going to talk about in this video lesson, there's only 3 ways to determine if two triangles are similar, not 5 ways. And those 3 ways are S, S, S. So that's common between congruent and similar. S, A, S. That's common between congruent and similar. And A, A. And that's kind of common between congruent and similar. Notice over here in similar, we have to include a side either in the included position or non-included position to determine congruence. We have to have a side measure. That's not present in similar. We've got the angle part in common, but we don't have to include a side measure. The other thing to notice is I'm only talking about 2 angles. We don't have to know the third angle measurement. So this is our similarities and differences between congruent and similar triangles, okay? Now let's start looking at these 3 shortcuts or 3 ways to prove that 2 triangles are similar. Okay, let's first look at the angle-angle similarity. Angle-angle similarity postulate says if 2 angles of one triangle are congruent to 2 angles of another triangle, then those 2 triangles are similar. So all we need to know is that we've been given 2 pairs of congruent angles. So in this picture, I'm being given that angle A is congruent to angle D, and angle B is congruent to angle E. That is all the information I need to know that these 2 triangles are similar. So I can go from this given statement to the conclusion that triangle ABC is similar to, here's our symbol for similar to, notice it looks a lot like is congruent to, but it doesn't have the equal sign because these are not equal in size. So there is no equal sign. So we have triangle ABC is similar to triangle. Now we have to match up our angle pairs. So angle A is congruent to angle D. Angle B is marked congruent to angle E. So that would mean angle C is congruent to angle F. So here, remember that the order matters. So this is our first similarity postulate. If 2 angles of one triangle are congruent to 2 angles of another triangle, there's our comma, so this is the given, then the two triangles are similar. There's our if part of the statement, and here's our then part of the statement. All right, let's check out another one. Next, we're looking at the SSS similarity postulate, side, side, side. It says, if the measures of the corresponding sides of two triangles are proportional, not congruent, proportional, then the triangles are similar. So let's see what's been given to us here in the first part of the statement. If the measures of the corresponding angles of two triangles are proportional. So let's revisit how to write up a proportional similarity statement. Let's start with side AB. Side AB is the smallest side of this triangle, and it would be corresponding to side DE, which is the smallest side of the second triangle. So AB matches up with DE. Then we've got the medium side, BC, and that matches up with the medium side of the larger triangle, EF. So BC over EF will produce the same ratio as AB over DE. We've got one more, the longest side. AC is the longest side on the smaller triangle, and it's a corresponding match to DF. So here's what's given to me. Now, I'm going to write this up in numeric form so you see that all three of these are equal to each other. So first, let's look at AB over DE. AB is 5. DE is 10. Okay, moving on to BC over EF. BC is 8. EF is 16. And then the last piece, AC is 11. DF is 22. All three of these ratios reduce to the same value. They're all equal to each other. They all equal 1/2. Reduce each of those fractions, and you're going to see that they all equal 1/2. There's a special word for that value. Remember, that word is scale factor. This is the scale factor. It's saying that the smaller triangle is exactly half the size of the larger triangle. So that's the scale factor here. So that's what's given by the picture. The picture tells us that all the measures of the corresponding sides of these two triangles are proportional. Now that's the if part of our statement, which means the then part here reads that the triangles are similar. So as long as you know that all three sides share a scale factor value, then you can write up a similarity statement. Triangle ABC is similar to, now make sure you match it up. A to B is the small side, B to C is the medium side, C back to A is the long side. So we're going small, medium, long. So we follow that same pattern. DEF will give us that exact same pattern. So triangle ABC is similar to triangle DEF. Okay, we have one more to unpack here. Take a look at our last postulate. This is called the side angle side postulate. Now, the side angle side similarity is very similar to side angle side congruence. The one thing that's changing is that the sides are not going to be congruent, but they are going to be proportional. Let's read through. If the measures of two sides of a triangle are proportional to the measures of two corresponding sides of another triangle, and the angles between them are congruent, then you have triangles that are similar. So it's kind of a merger of the first two postulates we've gone over. We've got two sides that are proportional to one another and one angle that is congruent to one another. So here should be our given. Let's go with the sides first. Side AB, that's the small side, would match up with side DE, the other small side. Another corresponding part would be AC, that's the longer side, would match up with DF, the other long side. Okay, that's all we know about this picture. We don't know anything about BC and EF, so we have to leave that out. I am using the exact same values from our previous postulate, so this next part is a repeated statement. AB is 5, DE is 10, AC is 11, DF is 22. We've already talked about how both of these two ratios reduce to 1/2, which is the scale factor. So because they both reduce to the same thing, the two sides of the two triangles are proportional to one another. Now we have another piece, this and part right here. This and part says, and the angles between these sides are congruent. So we have another piece of given information. And angle A is congruent to angle D. There's our other piece of information. We've just looked at the sides. That is true. Now we're looking at the angles between the sides, angle A and angle D. So these are the two things we would have to be able to discover or be given in order to claim these two triangles by SAS. Now that we've done that, we can write a similarity statement. I'm going to mix this first one up just to make sure everybody's paying attention here. I'm going to say triangle CAB. Now, when you write out the similarity statement, you have to match corresponding pieces. So I went from C to A, which is down the long piece, which means I have to go from F to D, also down the long piece. So F to D. Then I went from A to B, up the small piece. So I have to go from D to E, up the small piece. So when you're writing out your similarity statement, remember the order does matter. You have to match up your corresponding parts. Okay, in the last part of this video, we're going to run through some examples. Directions say, for the following examples, first things first, determine if the pairs of triangles are similar. If they are, you have to justify the answer. Okay, so SAS, SSS, and AA are our three options. So let me walk you through here. In this first picture, if these two triangles are similar, it's going to be by SSS because there are no angles given in the picture. So our question here is, are these similar by SSS? Well, the only way to know is go back on up the page here to the SSS similarity statement. The only way to know if they are similar is if the three measures all reduce to the same scale factor, meaning the sides are proportional to one another. So let's check that out. I'm going to go small, medium, large sides to make this easier. The smallest side on the top triangle is 4. The smallest side on the large triangle is 2. So 4 to 2 is a match. Small and small. Those are corresponding. All right, the medium side of the upper triangle is 8. The medium side on the lower triangle is 4. So that's a match. And then finally, the longest side on the upper triangle is 10, and the longest side on the lower triangle is 5. If all of these reduce to the same value, known as the scale factor, then we have a set of similar triangles. 4 over 2 reduces to 2. 8 over 4 reduces to 2. 10 over 5 reduces to 2. They all reduce to the same scale factor, which means the top triangle is twice as big as the bottom triangle. So that means these are congruent by SSS. Yes, they are. So we need to write up a similarity statement and justify it by SSS. So I'm going to start with triangle LMN. And we've got to come up with the correct order for the second triangle. Well, LMN goes up the small side, down the medium side. So we need to go up the small side, down the medium side when we're writing up our second triangle. That would go from D to E to F. So what I've said here, final answer, I'm going to put my little final answer symbol out front. Final answer, triangle LMN is similar to triangle DEF by the SSS similarity postulate. SSS similarity postulate. So I'm fulfilling the directions. It says first, determine if they are similar. If they are, state that they're similar and justify the answer. Okay, let's try example number 2. In example number 2, it looks like my only option is going to be AA. Notice there's no side values here. I'm not given any side values. So if these two triangles are similar, it's going to be by AA. All right, well, in what's given in the picture here, I definitely have 130 degrees present in both triangles. So we definitely have one of the angles taken care of. Now I need to discover if there's a second set of angles taken care of. This 30 does not match the 20, but I know that 3 angles in a triangle have to add up to 180 degrees. So 180 degrees minus the 130 degree angle and the 30 degree angle given on this top triangle is going to leave me with 20 degrees for angle K. Now we're talking. Now we have a second set of congruent angles. As long as we have 2 angles congruent to one another, we have a set of triangles that are congruent by AA. So it's time to write out our statement. Here's our similarity statement. I'm going to start with IJK. Triangle IJK is similar to, all right, let's pause and match everything up. Angle I is 30 degrees. Angle J is 130 degrees. Angle K is 20 degrees. Down here in the second triangle, angle W is 30 degrees. Angle Y is 130 degrees. Angle X is 20 degrees. And these two triangles are similar by the AA similarity postulate. Okay, flip your page with me. What I want you to do is try to discover if example 3 and 4 are similar. I'm going to pause the video and I'm going to do my work, and then when I come back, I'll have my work shown for you. Okay, here's what I've got so far. I decided for example 3, the only possible way that these two triangles could be similar is by the SSS postulate. I've got no mention about angles here, so I can't use angle values. So what I did is I've matched up the small side with the small side and the long side with the long side. What I'm discovering here is that these are not proportional. They are not. Let's check it out. If we try to reduce 8 over 4, we're going to get 2. If we try to reduce 12 over 7, we are not going to get 2. It reduces to 12 over 7. So that means all 3 sides are not in proportion with each other. So if all 3 sides are not proportional, then it is not the SSS postulate, which means these two triangles are not similar. Not similar. All right, in example 4, I decided the only possible way these two triangles were similar is by SAS, given the pattern. I've got two sides with the included angle. So I'm checking out the sides. I got 4/6 as the two small sides and 6/9 as the two long sides, misspelled that, but 6/9 as the two long sides. And I'm about to discover that these two are going to reduce to the same thing. 4/6 reduces to 2/3. 6/9 reduces to 2/3. So these are proportional to one another. Also, in the picture over here, I've got 74 and 74 degree angles as the included angles. So these do fulfill the SAS similarity postulate. So it's time to write up the similarity statement. I'm going to start with the smaller triangle RQP. Now, we have to make a similarity statement, so we have to match up angles. Angle R to angle Q to angle P goes down the small side, out the long side. To match that up, I have to start at angle C, go up the small side to angle B, and then down the long side out to angle A. And these are similar by the SAS similarity postulate. Awesome. Okay. These last examples I have here, example 5 and 6 and 7, these three, switch it up a little bit, okay? In these three examples, here we go. In these three examples, what we have is we are being told that the triangles are similar. So we're not trying to determine if they're similar anymore. We know they're similar. So if we know they are similar, then there are certain things we already know. We know that the sides are proportional and the angles are congruent. Now, we've already done a lot of work with congruent angles, so I didn't include any of those examples. What you're seeing here is all side work. See how every value is about the sides. So you're seeing all side work. So we're going to practice one more time our proportional side solving. We're told the two triangles are similar. So now we've got to set up a proportion and solve for x. And then we're taking it one step further and we're going to plug in for a missing value. Let me start with number 5. Here I'm given triangle BCD is similar to triangle RST. So I'm looking right here at where x is. Okay, x is in SR. 11x minus 4. SR can be compared to CB. Those are in the same position of the similarity statement. SR and CB. So SR can be compared to 60. Then I've got ST measured as 70. Those are in the last two positions. And DC or CD measured as 50. So 70/50. Now, I know these proportions are equal. These ratios are equal because this already has told me that the triangles are similar. So to solve, we're going to cross multiply. Let's see. This 50 is going to multiply the 11x minus 4, and 60 is going to multiply with 70. This is an opportunity to distribute. 50 times 11 is 550x, and 50 times 4 is 200. 60 times 70 is 4,200. To solve for x, I need to add 200 to both sides. That's going to give me 550x is equal to 4,400. And now I need to divide both sides by 550. I'm getting x equal to 8. Now, before I circle that and say I'm all done, I need to go back and read these directions. The directions say solve for SR. Find the length from S to R. So I'm not done yet. I need to go back up into my picture and I need to solve for this missing measurement, which means I need to substitute the X in where the value of X in for the variable X. So SR is going to be 11 times 8 minus 4. Well, 11 times 8 is 88, and 88 minus 4 is 84. So my final answer, SR, is equal to 84. Okay, I'm going to help you set up example 6, and then I want you to solve. Let's take a look. Given triangle ABC is similar to triangle FED. Now check out where your variable is. Your variable is on side CB. Okay, so that 11x plus 11 has to be compared to ED, the length from E to D, which is 30. 77 is on AB, which can be compared to whatever is on FE, which is 21. So here is the proportion that matches this similarity statement. Take a moment and solve for X. Okay, here I'm showing my work on how I would cross multiply and solve for X. I got a value of X equals 9. That is not the answer to the question. Make sure you read the directions to the question and make sure you know what they're asking for. This question wants us to find the value from B to C. To do that, we have to plug back into the 11x plus 11. So take a moment, use your value of x equals 9, and substitute it back in to find the value from B to C.